All right, so this is the third video for 2.4, and we're now going to write an equation for a quadratic if you're given 3 or more points. And also, when we're given points, we're going to talk about how to determine if those points are better represented with a linear function or a quadratic function. And we do that by finding the differences. And so down here it's shown like the difference between 9 and 4 is the differences in the output, which is the y values. And it takes the 4 and it subtracts the 9, you get -5. Then you take 1, subtract the 4, you always take the one on the right, subtract the one on the left, you get -3. Okay, if all of these were the same, it would be linear. If the first differences are the same, then you have a linear function. If they're not all the same, then you take the difference of those. So I would take the difference of -3 minus -5, I get +2. -1 minus -3 is a +2. So once the second difference is all the same, this means it is a quadratic function. You'll get a quadratic equation. Okay, so that's going to come out to play later. But right now, go on to number 5. And we're going to look at these, and just for practice, because in some of the practice that you're going to be assigned at the end of this video, you're going to have to find those differences. So I'm going to find the difference between these two outputs. Okay, remember it's the y value, so if this is x, this is y. So 20.4 minus 19.1 is 1.3. 19.9 minus 20.4 is a -0.5. 17.6 minus 19.9 is a -2.3. And 13.5 minus 17.6 is a -4.1. So I can tell right there this is not linear because those are not all the same number. So I'm going to do it again. -0.5 minus 1.3 is a -1.8. -2.3 minus a -0.5 is a -1.8. So many negatives I'm saying. All right, and a -4.1 minus a -2.3 is a -1.8. So because our second differences are the same, I know this is quadratic. That is not necessary for this problem, but like I said, it's going to be necessary for some of the practice problems that you have. So with this problem, now I'm going to erase that, okay? So that's going to help you with some of those other problems, so you need to understand taking differences. All right, so a former NASA employee designs a model airplane that flies in a parabolic path. The table shows the height in feet of a plane t seconds after starting the flight path. Write and evaluate a function to approximate the height of the model of the airplane after 6.5. So, 6.5 seconds. So this has 2 things to it. So first we need to write the equation, and then we're going to use that equation to find its height after 6.5 seconds. So we're going to use the 3-point method, and we're going to end up with our equation in standard form. So I'm just going to pick the first 3 points, and I write them out. So I have the point 1 and then 19.1. I have the point 2, 20.4. And I have the point 3, 19.9. It does not matter which 3 equations you use. You just need to pick, which 3 points you use. You just need to pick 3. But we're going to use these points and we're going to write equations. So if I write this into my ax squared plus bx plus c, we're going to have a times x squared is 1. Actually, I'm going to pause just for a second. Well, I'm going to pause. You're not going to notice it, but I'm going to rewrite this just a little bit. But leave yours the same. You'll see what I'm doing. Okay, I just had to give myself a little more room because I want ax squared plus bx plus c. And I'm just writing that. Usually we say y equals, but I'm going to put that at the end. Okay, so that way you know where my equations are coming from. So at least write that off to the side if you can't write it above it. Okay, so I'm going to plug these in. I'm going to have a times x squared, which is 1. And I don't know why I just used different colors. Let me just go back. I'm struggling, sorry. Okay, a times x squared, which is 1, plus b times x, which is 1 right here. And then we don't know c, so plus c is going to equal y, which is 19.1. So there's one equation. Okay, so I'm going to number my equation number 1. Okay, that does simplify, and I'm going to go ahead and simplify it within here by erase a little bit, but 1 squared is 1, and then b times 1 is b. So I really have a plus b, because 1 squared being 1, so it's 1a. B times 1 is b, so my first equation is a plus b plus c equals 19.1. All right, a on this next equation is being multiplied by x squared, and x is 2. 2 squared is 4, so I have 4 times a, or a times 4, okay? But we're used to seeing that coefficient in the front. And then it's plus b times x. Well, x is 2, so I'm going to have 2 times b. We don't know c, and it's not being multiplied by x or y, but it equals y, which is 20.4. So there's my equation 2. Then I'm going to plug it in, the third point in for x and y. So again, a times x squared, and x is 3, so I'm going to have 9a, because 3 squared is 9, plus b times x, x is 3, so I have 3 times b, plus c equals 19.9. And that gave me equation number 3. So now we have a 3-variable system. So this goes back to 1.4. And I'm going to take these and I'm going to solve for some variables. If you look, all of your c's are the same. So you could use your calculator, you could plug these in and use that equation solver. But I'm going to actually just solve these out. So I'm going to take equation 2 and I'm going to subtract equation 1. Okay, I'm not going to write them out. I'm just going to look and just do this, okay? So I have equation 2 is 4a minus a gives me 3a. Equation 2 is 2b minus b is 1b, so I have plus b. And then I have c minus c is 0, so I don't need to write that. And then I have 20.4 minus 19.1 is 1.3. Okay? So there's one equation. I got rid of a variable. So let's do this again. I'm going to take 3 minus equation 1. So I have 9 minus a, 9a minus a is 8a. 3b minus b is 2b. C minus c is 0. So I don't have to write a c. And then 19.9 minus 19.1 is 0.8. Okay? So this gave me equations 4 and 5. All right. Now I need to get rid of a variable again. So I can see that my b's are going to be a little easier to get rid of. So if I take equation 3, which has a positive 2b, then I want equation 4, I'm sorry, I said equation 3. If I take equation 5, which has a positive 2b, then I want equation 4 to have a negative 2b, okay? So I'm going to subtract 2, that's that minus 2 times equation 4, okay? So I have equation, and I wrote equation 3. I'm so sorry. I wrote equation 3, but this was equation 5, okay? So equation 5 is 8a minus 2 times equation 4. So that's a negative 6. So I have 8a minus 6. Oh, gosh. Things are disappearing. Okay. Is 2a. And then I have 2b minus 2 times 1b, which is 2b. So 2b minus 2b is 0. So I'm gone. B is gone. Then I have 0.8 minus 2 times 1.3, and I get a negative 1.8. To finish solving for a, I'm going to divide both sides by 2, and I get that a is a negative 0.9. So there's a. I need b, so I'm going to take it, I'm going to plug it back into number 4 here. All right, so I have 3 times a negative 0.9 plus b equals 1.3. And solve for b, I end up getting b is 4. And I'm going to plug both of those into equation 1 here. So I have a negative 0.9 plus 4 plus c equals 19.1. Okay, I'm going to go ahead and solve for c, and I end up getting c is 16. Okay, I'm not taking the time to step through those because that is from 1.4. Okay, we just combine like terms and get the variable by itself. So if I write this out as y equals, and it's a, which is negative 0.9 times x squared, plus, and I'm using this equation right here, okay, plus b times x plus c. Okay, now the only thing is my variables were not x and y. So y is h here, so I'm going to replace that with an h. X is t, so negative 0.9 t squared plus 4 times t plus 16. Now it's written with the variables that the problem called for. All right, I'm going to erase a little bit of my scribbles up here. We need to find the height. So that was part 1 of this problem. But now we need to find the height after 6.5 seconds. Okay, well, our t is our seconds there. So h is going to equal, if I plug in 6.5 for t. Okay, type all of that in your calculator, and you end up getting approximately 4 feet. It gave you 3.975, which is approximately 4 feet. All right, go to number 6. And again, if we look at differences here, the first difference is 180. 180 minus 0. 270 minus 180 is 540. 1620 minus 720 is 900. Again, this is not linear because those are different. All right, so we find the differences of those. So 540 minus 180 is 360. 900 minus 540 is 360. So those are the same, so now I know this is quadratic. Okay? Actually, and then I'm just going to erase this much, and you'll see why those other numbers might come into play later. Might not, but we'll see. Okay. So we have to do our 3-variable system, and then we will end up plugging into our final equation. If the circumference is 10, what is the safe working load, okay? So we write our variables, and I'm going to do this out to the side over here just because I have more room. I write a little big. So my equations, remember, it is y equals ax squared plus bx plus c. And we're going to use, I just use the first points. If I use 0, 0, 1, 180, and 2, 720. All right, so I get, and I'm going to end up moving the y to the right side just for the purpose of these, because of how we're used to seeing our 3-variable systems. Now, if I get that x is 0, those are zeros. A times 0 squared is 0. B times 0 is 0. So I'm going to end up with c equals 0, because it's c, remember I'm moving the y over to that side, group over there. So I have c already. That's convenient. All right, let's do the next equation, where if 1 is x, so I have a times 1 squared is 1 times a, so I just have a, plus b times 1 is just b, plus c is going to equal y, which is 180. Okay, let's do that again for this last problem here. I have a times x squared, and x is 2, so 2 squared is 4, plus b times x, so 2b, plus c is going to equal 720, which is the y value. Okay, now if c is 0, really in any of these, this can turn to 0. It's nothing, it's gone. So I can use the second equation, so remember this equation 1, 2, and 3. I can just use 2 and 3 to solve for either a or b. So let's just solve for b, it has lower numbers there. So I'm going to take equation 3 and I'm going to subtract equation 2. The only problem is I need that b to be a 2 for it to work out. So I'm going to say minus 2. Oops, I got rid of it. There it goes. So, because if this is 2b minus, and that was a 2b, it would be 0. So that will work out. So let's try this. Okay. 4, which is my equation 3, minus 2 times equation 2. Okay, so 4 minus 2 times 1. So 4 minus 2 is 2a. Then I have 2b minus 2 times b is 2b minus 2b is 0. All right, now let's take equation 3, the 720, and subtract 2 times 180. And if you do that, you get 360. And if we want to solve for a, I'm going to divide by 2. I get a is 180. So now I have a and c, and I need to find b. So I'm just going to take this for a, and I'm going to plug it into this equation right there, because then I can solve really quickly. Okay, so if I'm doing equation 2 here, and I have a is 180 plus b, c is 0, so it's gone, equals 180. So I actually end up with b is 0 as well. So if I plug them in to my equation, my standard form, I end up with y equals a, which we said was 180 times x squared, plus b, which is 0 times x, which is 0, plus c, which is 0. This is my equation. All right, and then it says, back in the problem here, oops, I'm going to zoom out a little bit. So our equation was y equals 180x squared. Oh, but look, they use different variables, okay? So their x, it's not letting me write. Their x is c and their y is an s. So that means s equals 180 times c squared. So there's our actual equation. Sorry, I should read the problem a little better. And now it wants, if the circumference is 10 inches, what is the safe working load, okay? So I'm going to take 180, and I'm plugging in 10 for the circumference and squaring it. So 10 squared is 100, times 180 is 18,000, and it's workload, and it says up here our workload S is in pounds, so it's 18,000 pounds. All right, so that's going to be the end of this video. I'm coming over here. Now I want you to do in the practice problems number 24, 25, and 26. And then problems number 29 and 30 at the end of the practice in the packet. Those ones are dealing with those differences, okay? But it's still solving using the 3 points. And then move on to the last video.